Hello, everyone. Before we get into machine learning, models, or architecture, I want to start with a simple idea. Third party risk management was never designed for scale, speed, or complexity we operate in today. Most third party programs were built for periodic reviews, static questionnaires, and manual judgments. But today, enterprises depend on hundreds, sometimes thousands of third parties operating across cloud, or APIs, global supply chains, and regulated financial ecosystems. And risk doesn't wait for annual reviews. So today I want to show you how we have been re-architecting TPRM as a machine learning driven intelligence system, not just a compliance function. This is not theoretical. This is what we have actually being built, tested, broken, and rebuilt at scale. Let me start with a quick introduction so you know where these lessons are coming from. My name is Sagar Behere, and I lead third-party risk management oversight at a blockchain-based stablecoin company. We operate in the digital financial ecosystem, and we are a FinTech and one of the largest issuer of stablecoin globally. The reason I mentioned that is because we operate in a high-risk, fast-changing environment where regulatory expectations evolve quickly, vendors change constantly, and risk signals shift in real time. I've spent over a decade across third party and enterprise risk in many Fortune 100s, Big Four consulting, fintech, FANGs. Across all of these environments, one pattern kept repeating. Risk teams were doing the right thing, but the system itself wasn't designed for speed, scale, or intelligence. My work today sits at an intersection of risk management, machine learning, and automation. Not to cut corners, but to make risk management smarter, faster, and more defensible. So, what you'll hear today isn't a theory or a vendor pitch, it's a playbook we use to reduce our onboarding time dramatically while improving risk outcomes, auditability, and regulatory confidence. I am sure many of you have already experimenting with AI or machine learning in your third-party risk management programs. My goal here today is simple. I want you to walk away with 2 or 3 ideas you can actually take back and apply to your program or your platform or even your product roadmap. All right, before we talk about solutions, I want to level set on a problem we are all dealing with. Modern enterprises don't just have vendors anymore, they have an entire ecosystem. Hundreds, sometimes thousands of third parties. Your cloud providers, SaaS platforms, payment processors, data vendors, open source dependencies. Each one expand your attack surface and more importantly, your risk surface. But most traditional programs were designed for a very different world. They assume risk changes slowly. They assume reviews can happen annually or quarterly. They assume static questionnaires and manual reviews are enough. That assumption no longer holds. Risk today moves at a speed of software, not at the speed of audit cycles. At the same time, regulatory expectations are going in the opposite direction. Not looser, but tighter. More transparency, more explainability, more continuous oversight. So we are stuck with a contradiction. We are expected to move faster while proving more using systems that were never designed to scale this way. And the contradiction shows up very clearly in our traditional risk management structure. Moving on to next slide, the traditional structural misalignment. This slide is very uncomfortable because it describes how most of us have been trained. Let's start with the calendar-based reviews. Annual or quarterly assessment assume risk politely waits its turn. But breaches, outages, financial distress, they don't care about your review calendars. If something changes in month 2, you don't discover until month 12. And that's if you're lucky. Your next is static questionnaires. one-size-fit-all surveys, same questions, same order, same depth, regardless of vendor profile. So low-risk vendors buried in unnecessary questions, and high-risk vendors often don't get the depth they deserve. Everyone is frustrated. Your vendors, your business teams, and of course, your risk teams as well. And finally, over there is manual evidence review. Humans reading hundreds of unstructured documents, your policies, SOC reports, certifications, PDF after PDF stacked. They don't just create bottleneck, it creates inconsistencies. Imagine these two analysts can read the same document and each reach different conclusions. And neither one is technically wrong. So, what we end up with is not a people problem, it's a structural misalignment between how risk behaves today and how TPRM systems were originally designed. And that realization is what forced us to rethink TPRM, not as a checklist or process, but an intelligent system. So the question becomes, if this model doesn't scale, then what does? So once you accept that the traditional TPRM doesn't scale, the real question becomes, what does scalable model actually look like? For us, the answer wasn't add more people or buy bigger tools. It was re-architecting TPRM as a machine learning driven system. And at a higher level, this architecture has 4 moving parts, which I've listed over there on the slide. First one is data ingestion. So instead of relying only on what vendor sends, we ingest data continuously through policies, attestations, public disclosures, threat intelligence, financial signals. The goal is simple. Do not wait for risk to be observe it directly wherever possible. Second is intelligent processing. This is where machine learning and NLP starts doing the heavy lifting. Extracting control evidence from unstructured document, normalizing it and making it comparable. Humans are great at judgment. They're not great at reading some 300 policies. Then we move into risk evaluation. Instead of static scoring, we evaluate risk dynamically based on vendor risk profiles, your critical control maturity, and observed signals. And just as important, every determination comes with explainability and not just score. And finally, you have continuous monitoring. This is where the biggest shift happens. TPRM stops being episodic and starts behaving like a living system. The architecture runs continuously, not annually. One of the first bottlenecks we attacked was manual evidence review. Think about how much time TPRM team spends reading PDFs or your SOC reports. This is where natural language processing changed everything for us. We trained NLP models to extract and normalize control evidences from unstructured vendor artifacts. Instead of asking, does this document look okay? The model asks, does this document demonstrate the control we actually care about? It identifies the control, extracts the relevant text, maps it back to the requirements. And this is critical. Every extracted data point maintains full traceability. You can click from risk conclusion all the way back to risk extract sentences in the source document. That matters not just for audit, but for trust. The impact were immediate. Thousands of documents processed automatically, massive reduction in manual workload, and far more consistent outcomes across reviewers. Humans didn't disappear from the process. They moved up the value chain, from reading documents to validating judgments. Once evidence extraction was no longer the bottleneck, we could tackle something even bigger, that is redundancy. Once we solved the document review, we ran into a different problem. We were still asking vendors way too many questions. And not because we loved questionnaire, but because the different frameworks kept asking the same thing in a slightly different way. So we turned to semantic similarity models. Instead of treating question as a text string, we treated them as meaning. If two questions are asking for the same control, the system knows it, even if the wording is completely different. That resulted in eliminating redundancies. The model clusters overlapping questions across frameworks, be it SOC, your ISO's internal policy, or regulatory requirement. So instead of five nearly identical questions, the vendor sees one intelligent question. That alone removed a lot of friction. But we didn't just stop there. The system adapts follow up questions based on how the vendor answers. If the control clearly exists and is mature, we move on. If something looks weak and ambiguous, that's where we dig deep. Depth where it matters and speed where it doesn't. And finally, context aware routing. Instead of dumping every question on a single vendor contact, the model routes the question to the right stakeholder, security to security SMEs, finance to finance teams. Response quality went straight up, back and forth went straight down. That is the moment the vendor stopped saying, "This feels painful," and started saying, "This actually makes sense." Now, if you're relying on machine learning this heavily, there's a natural question that comes up. Whenever I talk to ML in risk management, someone inevitably will ask, "But what if the model is wrong?" That's the right question to ask. We never trust a single model to make a risk determination. Instead, we use ensembling models, multiple independent models evaluating the same risk signal. Each model looks at data slightly different, and if they agree, confidence goes up. If they disagree, the system flags for cases automatically. So every risk output comes with a confidence score. High confidence, the workflow moves forward. Low confidence, a human steps in. We didn't remove human judgment, we aimed it where it actually adds value. This also solved a major governance concern: single model bias, black box decisions, regulatory explainability. With multiple models, you can explain why a conclusion was reached and how confident we are in it. So, at this point, something important has changed. TPRM was no longer just fast, it was smarter, more consistent, and more defensible. And that set the stage for a bigger shift of all, moving from a periodic review to a continuous intelligence. Up until now, everything I've shown you focused on making assessments better. But the real breakthrough happened when we stopped asking, "How do you improve reviews?" and started asking instead, "Why are we still relying on reviews at all?" Traditional TPRM assumes risks changes slowly, so we check it periodically. But modern risk doesn't behave that way. So we moved from periodic assessments to an event-driven monitoring. Instead of waiting for 12 months to rediscover risk, system continuously ingests signals from multiple domains. When something materially changes, a vulnerability disclosure, a breach notification, a financial signal, an operational anomaly, the system doesn't wait, it reacts. And that is the important distinction. We are not continuously reassessing everything all the time. That would just create a noise at a faster speed. But we are listening for meaningful events and only then triggering actions. So TPRM stops being a calendar-driven process and starts behaving like a monitoring capability. The obvious next question is, what exactly are we monitoring? To make continuous monitoring work, we need diverse, reliable data. We group our inputs into 5 primary signal categories. First, threat intelligence. Real-time feeds, vulnerability databases, indicators of compromise. This gives us early visibility into emerging cyber risk, often before vendor formally discloses them. Second, security advisories. CVE disclosures, vendor bulletins, patch announcements. When something critical drops, we know immediately. And we can correlate it to the affected vendors. Third, financial indicators, credit ratings, earnings signals, market stress indicators. Because distress often shows up before a operational failure. And fourth, public disclosures, breach notifications, regulatory finding, enforcement actions. These are high signal events and they deserve immediate attention. And finally, the behavioral patterns, change in vendor behavior, operational anomalies, shift in activity. These are often subtle but incredibly powerful when you see them early. Individually, none of these signals tell you the full story. But when you correlate them across domains and over time, you start seeing risk forming, not just risk reported. That's what allows us to move from detection to prediction. Up to this point, we have been talking about detection. But the real value of machine learning in TPRM isn't just detecting risk faster, it's detecting risk before it fully materializes. This is where predictive risk detection comes in. We have trained models on historic incident data across cyber events, your operational failures, and financial stress scenarios. The goal wasn't to predict the exact next breach, but the goal was to identify patterns that tend to slow up before anything goes wrong. What we found was very interesting. Major incidences are rarely random. They usually they're usually preceded by subtle signals, such as missed patches, delayed disclosures, changes in operational behavior, financial stress. Individually, these signals look harmless. But when you analyze them together, over time, patterns start to emerge. That's where machine learning excels. Connecting weak signals humans would never correlate manually. So instead of reacting after an incident, we can intervene early, ask targeted questions, trigger reassessments, or escalate controls before impact. This is the difference between managing risk and anticipating. Now, whenever you talk about prediction and machine learning in regulated environment, that's a very reasonable concern that always comes up. The question is, how do you explain this to an auditor, to a regulator, or even your senior leadership? Because prediction without explainability, it's just a guesswork. And that's not acceptable in risk management, right? So, the first design principle we enforced was transparent reasoning. Every risk score comes with explanation, which factors contributed, how strongly, and why they mattered. No black boxes. Second, audit trail preservation. Every decision is traceable end to end, from source data to model output to final human. If someone asks, why did we rate this vendor high? You can show them precisely. And finally, regulatory alignment. This architecture was built with regulatory expectation in mind. That is transparency, defensibility, and consistency. Machine learning didn't weaken our governance model, it strengthened it. At this point, TPRM stops being viewed as a compliance obligation. It starts being seen as a trusted intelligence capability. And that shift had very real business impact. So let's talk about what all of this actually delivered. Not in theory, but in practice. First, scale. We can now assess and continuously monitor thousands of vendors without growing headcount at the same rate. That's critical because vendor ecosystems grow faster than risk teams ever will. Second, response velocity. What used to take weeks or months, we can now detect and respond in an hour, in hours. The time difference matters, especially when you are dealing with cyber, operational, financial risk. Third is consistency. Machine learning helped us standardize how risk is evaluated, reducing reviewer to reviewer variability. That makes outcome more predictable and far easier to defend. And finally, strategic intelligence. TPRM stopped being a back office function. It became a source of insight for leadership, highlighting concentration risk, systemic exposure, and emerging patterns across the ecosystem. And that brings me to the most important shift of all for TPRM. When you step back, what machine learning really did for us wasn't just automation, it changed how TPRM is perceived. Instead of being a compliance check the box, TPRM became a core intelligent capability inside a resilient digital ecosystem, one that combines scale, explainability, and adaptability. Machine learning gave us the ability to see risk earlier, respond faster, explain decisions clearer, and adapt continuously as vendor and threat evolved. That combination is what regulators expect. It's what leadership needs, and it's what modern digital ecosystem requires. This is what allows organizations to move faster without losing control. So let me leave you with one final thought. If there's one thing I hope you take away from today, it's this: machine learning doesn't replace risk judgment, it amplifies it. You don't need to start with a perfect model or a massive transformation. Start small, automate evidence extraction, reduce redundant questions, introduce signal driven monitoring. But once risk teams stops chasing questionnaires, they start anticipating risk. With that, I would like to conclude. Thank you for your time and hope you all have a wonderful day ahead.